Hello students, I am Mohammad Asim. We are doing past papers of quadratic equations. In last lecture, we did one word problem from past papers November 96, and today we are doing one more questions of math past papers paper 2. You know paper 2 means where calculator is allowed, and the average mark of word problem of paper 2 is from 9 to 12. So this is question from past papers. This question came in November 2008, paper 2, question number 7. And this is another application, another uses of quadratic equation. In last lecture, we did quadratic equation, paper 2, word problem, where we apply the concept of quadratic equation in money exchange. Now, in these questions, we are applying the concept of quadratic equation in distance, time and speed, some sort of kinematics. So see how to use quadratic equation in this question. Question is a light aircraft flew from Maseru to Nata and returned to Maseru. It's a journey from one city to another city, Maseru to Nata and return to Maseru. Part A. The distance from Maseru to Nata is 1080 kilometer. Student, before I start part 1, you just keep in mind, for a journey from one point to another point and another point to backward point, the distance is always same. So see, the distance from Maseru to Nata is 1080 kilometer. So it is obvious the distance from Nata to Maseru is also 1080 kilometer. So you must keep in mind the outward journey and the backward journey, the distance is always same. Part 1. On the outward flight, the average speed of the aircraft was x kilometer per hour. From Maseru to Nata, the speed of the aircraft is x kilometer per hour. Write down an expression in terms of x. In terms of x means we have to see x in our expression. Write down an expression in terms of x for the time taken in hours. So we have to find the time. How to find the time? We must know the formula of speed. You know, the formula of speed is equals to distance upon time. So in this case, in part 1, the speed, outward speed is x kilometer. So replace this speed by x is equals to distance, you know, is also given, which is 1080. So x is equals to 1080 upon time. Time is required. So shift time to this side and x to this side. So hence time is equals to, this implies that time is equals to 1080 upon xr. So this is the answer of part 1. What is the question? Write down in terms of x for the time taken in hours. So time is equals to 1080 upon xr. This is the answer of part 1. Part 2. On the return flight. Return flight means from Nata to Maseru. On the return flight, the average speed was 30 km per hour greater than the average speed on the outward flight. So if speed is increased, in this case, you know, speed can increase, speed can decrease. When speed increases, time must be less, and when speed decreases, time must be increased. So on the return flight, the average speed was 30 km per hour greater than the average speed on the outward flight. What was the average speed of the outward flight? X kilometer. So our new speed must be x plus 30. Okay? Speed on the outward flight, write down an expression in terms of x for the time taken in hours on the return flight. Now again we will use the formula of speed is equals to distance upon time, but in this time the speed is x plus 30 km per hour, because speed is greater by 30 to the outward flight. So speed is x plus 30 is equals to, I already told you, distance doesn't change. No matter when the speed is increasing or decreasing, distance is always same. So x plus 30 is the new speed, is equals to 1080 is the distance upon time. Time is required. Move time to this side and x plus 30 to denominator. So new time is 1080 x plus 30. And student, you can see if the denominator is greater, the overall answer is shorter. In this case 1080 upon x, and in this case 1080 upon x plus 30. So this is big quantity and this is small quantity, okay, because the denominator is little bit high, little bit greater. How much greater? X plus 30 greater. So the answer of first part is time for the outward flight was 1080 upon x, and time of the backward flight is 1080 upon x plus 30. So this is the answer of part 2. Come to part B. There are two parts of part A. This is part B. The time taken on the return flight was half an hour less than the time taken on the outward flight. Obviously, you can see this time is short and this time is bigger because this denominator is x, the denominator is x plus 30. So this is short time and this is more time. How much more? Half an hour. The time taken on the return flight was half an hour less than the time taken on the outward flight. Form an equation in x and show that it reduces to x square plus 30x minus 64800 is equals to 0. And you can see again we have to make the quadratic equation with the help of these two conditions. This is condition number 1 and this is condition number 2. So according to question, time is taken on the return flight was half an hour less than the time taken on the outward flight. What was the time of outward flight? 1080 upon x. What was the time of backward? 1080 upon x plus 30. This is large time and this is a small time. So this is large time 1080 upon x minus this is small time 1080 upon x plus 30. How much difference? Is equals to 1 upon 2. Why we wrote 1 upon 2 over here? This is given. On the return flight was half an hour. So this is 1 upon 2. Now with the help of this condition we have to make the equation, this quadratic equation x square plus 30x minus 64800 is equals to 0. So take the LCM of x and x plus 30. X cancel to x, 1080 multiplied by x plus 30 minus x plus 30 to cancel x plus 30 and x directly multiplied by 1080 into x is equals to half is same. 1080 multiplied by x 30 is 1080 multiplied by x, 1080x and 1080 multiplied by 30 is 32400. Minus 1080 into x is just 1080x, and in denominator x into x, x square, x into 30, 30x. Okay, cancel this 1080x by 1080x because one is plus and one is minus. What is remain? 32400 upon x square plus 30x is equals to 1 upon 2. Now cross multiply this. This 2 is divided over here. This should multiply by this number 32400 into 2 is equals to x square plus 30x into 1. Anything which multiply by 1 is always same. So this is just x square plus 30x. 32400 multiplied by 2. The answer is 64800. You know this is paper 2 question, so you can use the calculator to multiply this by this. So 64800 is equals to x square plus 30x. Now shift this 64800 on this side. You will get x square plus 30x minus 64800 is equals to 0. This is what I need. X square plus 30x minus 64800 is equals to 0. The requirement has fulfilled, and this is the answer of part B. This is your final answer. Part C. Part C is solve the equation x square plus 30x minus 64800 is equals to 0. You know student, this is quadratic equation, and how to solve quadratic equation? By applying any method, the method of factorization, the method of completing square, the method of quadratic formula. And what I told you, if you see a big value like this 64800, this is 6000, this is 64,800, this is very big value. So if you see big value in quadratic equation, you always apply quadratic formula. How to apply quadratic formula? We need three constants, a, b and c. What is a? The coefficient of x square. In this case, the coefficient of x square is 1. What is b? The coefficient of x. The coefficient of x in this case is 30, and c is constant. What is constant? Is minus 64800. So if you see minus sign in a, b and c, you must write the number with minus sign. So c is in minus. Now put a, b and c in the quadratic formula. What is quadratic formula? X is equals to minus b plus minus b square minus 4ac root whole upon 2a. Now put this value. X is equals to minus b. Minus b is 30 plus minus b square. 30 square minus 4 into a into c. Here c is minus 64800. So minus 30 same plus minus 30 square is 900 minus minus plus 4 ones are 4 and 4 multiplied by 64800 is 259200. 259200 upon 2 ones are 2. Now next step, minus 30 plus minus 900 plus 259200 is 260100. And if you find the square root of 260100 by using calculator, the square root of 260100 is 510. X is equals to minus 30, 1 time plus 510 upon 2, comma, x is equals to minus 30, 1 time minus 510 upon 2. So 510 minus 30 divided by 2, the answer is 240. And minus 30 minus 510 upon 2, the answer is minus 270. You can verify these two answers by using calculator. So this is our final answer of part C. Part C is solve the equation. We have solved. This is our answer. The next part is part D. Calculate. It has two parts. In part D, we have two parts. Part 1 is calculate the time taken in hours on the outward flight. How to find the time taken in hours on the outward flight is, you can see the outward time is in part 1. Time is equals to 1080 upon x. So 1080 upon x is the outward time. But we have two values of x, 240 minus 270. So which value we have to put in this equation? Obviously student, we have to put the positive value. Why? Because time can never be negative. Time is always a positive quantity. So we have to put the positive value of x, that is 240. Hence time is equals to 1080 upon x. X is 240. If you divide 1080 upon 240 by calculator, you will get 4.5 hour. So this is the answer of part 1. The part 1 is the time taken in hours on the outward flight. The time taken in hours of outward flight is 4.5 hour. Now see part 2. Part 2 is calculate the average speed for the whole flight from Maseru to Nata and back to Maseru. We have to find the average speed of the whole journey from Maseru to Nata and from Nata to Maseru. It's very easy. You must know the formula of average speed. What is the formula of average speed? Average speed is equals to the total distance upon total time. If you Plug in total distance in numerator and plug in total distance in denominator, you will get the average speed. But students, I don't have enough space to do this part too, so I should rub some part of this question from this. I am doing this part too over here. So for average speed we need total distance upon total time. First we have to find total distance. You know that distance from Maseru to Nata is 1080, and I already told you the distance doesn't change. From Maseru to Nata is 1080, then Nata to Maseru is also 1080. What is the answer? 2160. 2160 kilometer. Now, so total distance is 2160 kilometer. Now find total time. Total time is from Maseru to Nata is 1080 upon x plus from Nata to Maseru backward is 1080 upon x plus 30. 1080 upon x we have already find in part 1 of D, which is 4.5. We have already find 4.5 r, and you can also find 1080 upon x is 240. So we have already calculated, so no need to calculate again, but we have to calculate this part. X is 240 plus 30. 4.5 is 1080 upon 270, which is equals to 4.5, and 1080 upon 270 is 4. So 4.5 plus 4 is 8.5 r. This is total time. I hope you understand. You can verify these values by using your calculator. Hence, our average speed for the whole journey is, what is the formula of average speed? Total distance upon total time. What is the total distance? 2160. What is the total time? 8.5. If you divide 2160 divided by 8.5, you will get 254 kilometer per hour. This is your answer, final answer. 254 kilometer per hour was the average speed of the aircraft. So average speed is always equals to the total distance upon total time. I hope you understand. So student, this is our today's class. We have done one more question from different type. In last lecture we did a question of quadratic equations involving currency exchange. In this question is also related to quadratic equation, but it involves the speed, time and distance. Students, I will give one more class to this topic, and I will choose another question which involve another type, but the topic was same, quadratic equation. So I hope you understand. Kindly do many questions of this type, and if you feel any difficulty in any questions, write in comment box. I promise you I will do the question in next lecture. Okay student, kindly do subscribe my channel and share my videos and like my videos and share to other friends as well. Okay students, see you in next class.